my dear students. A very good evening to all of you. Today, I will discuss about fluid dynamics. As you learn about fluid kinematics, also, so today we'll start fluid dynamics. Okay, let's start. In the previous chapter, we studied the velocity and acceleration to find in a fluid flow without taking into consideration the forces causing the flow. Today we will deal with mainly dynamics part of fluid mechanics. As you know, dynamics of fluid flow, the study of fluid motion with the forces causing flow. The dynamic behavior of the fluid flow is analyzed by the Newton's second law of motion, which relates the acceleration with the forces. According to Newton's second law of motion, Fx equal to m into x, or m equal to mass of fluid, and Fx equal to net force, and Ax equal to the acceleration. In the fluid flow, the following forces are present. Uh, Number one is gravity force. Number two is Fp, that is pressure force. Number three is Fc, that is force due to viscosity. Number four is Ft. Ft means force due to turbulence. Okay, and last one is Fc, is force due to compressibility. We will add these forces, then we will get net force. Okay, uh, how to get net force? Okay, let's write this. Net force equal to means Fx. Okay, Fx is equal to Fg, Fp, Fb, and Ft plus Fc. Summation of all the forces, then we get net force. Uh, if the last one means Fc. Okay, if Fc is negligible, then we will get equation, that is Fx is equal to Fc, Fp, Ft. Last one is Ft. That force is called, that total force is called, this equation is called actually Reynolds equation. Okay. That is Fx equal to Fg, Fp, Fb, Ft. And next one is Ft. If Ft is means turbulence is negligible, that equation is called Navier-Stokes equation. Okay, is the equation is Fx, Fgx, Fpx, Fbx, Ftx. As you know the all the term, Fg means gravity force, Fp means pressure force, Fb means force due to viscosity, Ft means force due to turbulence. Okay. Okay. okay, let's start it. The equation is fx equal to fgx plus fp plus x. Fg, this all equation is x direction. The force are in acting x direction actually. Okay. This equation is called Navier-Stokes equation. And the last one is, if the flow assumed to be ideal, viscous force means Fb0, then the equation of motion known as Euler equation of motion. Okay, let's write this. Number C. C is viscous force, or I write this B0 directly. This equation is called Euler's equation of motion actually. Yeah, this is Euler's equation of motion. Okay. Okay, I think you will be understand this relation. Okay, our next topic is deduction of Euler of equation of motion with its numerical form. I will draw the. You can see there is a consider a streamline. Which flow is taking place in this direction as shown in figure. You can see. Consider a cylindrical element which cross sectional area is dA. Okay, means dA, and length is ds. The forces acting on the cylinder element are number one pressure force. You can see there is written pressure force PdA in the direction in the flow. P plus del P del is opposite to the flow. Net force acting on the element, this PdA minus bracket P plus del P by del S into ds into dA minus along the force, it's opposite direction, so it will be minus rho gd dA ds cos theta equal to rho dA ds into as. Okay, now we know that a is equal to means acceleration equal to change of velocity with respect to time, means dv by dt. Okay, or v is a function of s and t. So this will be written, this can be written as del v by del s into ds by dt plus del v by del t. Now we know v equal to ds by dt, so we can write in as v del v by del s plus del b by del t. Okay, we know in steady flow del v by dt equal to 0, so it can be put as del v by dt equal to 0. Then we get as equal to v del v by del s, v del v by del s. Then we can substitute this value in this equation, means p delay minus p del p, that equation. Then we will get minus del p by del s into ds dA minus rho g dA ds cos theta equal to rho dA ds into del v by del s. Okay, now I can divide this equation by rho ds dA. Then I can get minus del p by rho ds minus g cos theta equal to, I can divide this section as rho ds by dA in that equation, okay, in both sections. So this will be rho ds dvds by rho ds dA. This will be cut and there will be left, that is equal to b del v by del s, okay. Or this can be written as this equation is written as del p by rho del s plus g cos theta plus b del b by del s equal to 0, okay. You can see that triangle portion means theta. You know theta is the angle between direction of flow and the line of action of the weight element, okay. So you can get this equation del p by rho into del s. Now put value of cos theta dz by ds and see, we'll get I 1 by rho dp by ds plus g dz by ds plus b del v by del s equal to 0. So after that we will get the Euler's equation of motion, means del dp by rho plus g dz plus v dv equal to 0. This is Euler's equation of motion. This is the final equation. Okay, this is Euler's equation of motion. Now how can we prove Bernoulli's equation from Euler's equation? This is our next deduction. So okay, let's start it. Let's start. We know Bernoulli's equation, the main form of Bernoulli's equation means p by rho g plus v square by 2g plus CD constant, and the Euler's equation is dp by rho plus g dz plus v dv equal to 0. Okay, okay, let's see. Listen to Euler's equation. Okay, so we know that dp by dp by rho plus dz plus v dv equal to 0. Then we integrating both sides, then we'll get integration on this side and get p by rho plus integrating g dz, this is g into z integrating v square by 2 constant. Then we'll get dividing g in all three terms, then I can get p by rho g plus z plus v square by 2g equal to constant. Then I can this equation rewritten as p by rho g plus v square by 2g plus z equal to constant. Okay, this is the main form of Bernoulli's equation. This is very important equation for exam. In any exam there will be some question related to this equation. Okay, now what is p by rho g and what is v square by 2g and what is z? Now p by rho g means actually pressure head, okay, pressure head, and now v square by 2g means velocity head. What is z? Z equal to data head or potential head. You can written as v square by 2g is equal to kinetic energy in terms of energy, z equal to potential energy, okay. In terms of energy I can written as p by rho g equal to pressure energy, v square by 2g kinetic energy, z equal to potential energy. Okay, now what can we assume from this equation? Okay, there is four assumption. The following are assumptions made in the derivation of Bernoulli's equation. uh, Number first one is fluid is ideal. Number two is the flow is steady. Number three is the flow is number two is flow is steady. Next, number three is the flow is incompressible. Next, number four, the flow is irrotational. Last one is the flow is irrotational. These are the assumptions of Bernoulli's equation. This is very important. Okay, that's all for today. In next session, I will discuss some numerical problem. Okay, thank you.